The moon, perhaps the most beautiful object in the night sky. We always see its same face from Earth. The moon orbits the Earth freely under gravity. However, the parts of both closer to each other experience more force than those further apart. This ends up distorting both bodies. This restricts the moon's rotation so it always shows the same face to Earth. This is tidal locking. It is also slowing down our rotation. We don't always see the full face of the moon. If we see the moon from the same direction as the sunlight, we see it fully illuminated. But usually, as the moon goes around the earth, we generally see it from other directions, and thus only a part of it is seen illuminated. The edge between the light and dark is usually where the sunlight hits the surface at an extremely large angle. This means that small changes in height cause large shadows, and we can see the surface irregularities well. Thus, craters and other features are prominent along here. Let us zoom in on a crater-filled region of the moon. There are sometimes craters within craters. Can you use this to identify in what order they were formed? Just by seeing which crater runs over the other, we can see which was formed first. What is a crater anyway? They form when the moon is hit by small stray objects. Since the moon has no atmosphere, these objects, called meteoroids, hit the surface at high speeds and boom, a crater. But wait, it's not it's not just that the material is pushed away by the impact. All craters are nearly circular, even though we know that rocks hit the moon from all angles. Also, almost all craters have this, a small hill at their centers. There is also an elevated ridge circling the craters. Observations like these have led us to come up with a proper understanding of crater formation. The characteristic shape results as, due to the hard impact, the surface deforms in a fluid-like manner. Now, apart from craters, the moon's surface is interesting by itself. We can see that there are dark flat plains as well as some light streaks on the surface. We see that the dark flat plains have fewer craters, so they must have formed later than the rest of the moon. These dark plains are called seas, but they have no water. It is now believed that as the early moon was bombarded with meteoroids, it triggered volcanism and caused lava outflows. As the lava cooled, it solidified, giving us the dark, smooth surface. The white streaks are called lunar rays, and we can see that they originate from certain craters. It is believed that these are the result of material from meteoroids being ejected by the impact. That's our moon! And this is the grandeur revealed just as we look. The universe has so much to tell, we just need to look.